you're going to look at a little bit more practice on arithmetic series. So I wanted to go through some practice problems with you and then have you do some guided practice. So remember that capital S sub n refers to series as opposed to A sub n referring to a sequence where you're just listing the terms. A series is when you're going to add together the terms. So remember our formula was our number of terms divided by 2, because that's our number of pairs, times the first term plus the last term. So if this was the 20th term, the first term plus the 20th term pair together, and you multiply that by the number of pairs. So this would be 10 if there were 20 terms. So in this first example, they've given us the first term. They've given us n is 14, so they've given us the 14th term. So we're ready to just use the formula. So the formula would be 14 divided by 2, 7 pairs, times 25 plus 259. So 7 times parentheses 25 plus 259 looks like 1988. So I wanted to review how to use sigma notation to do that same calculation. So I'm going from term 1 to term 14. It's actually harder to do it this way. This is an arithmetic sequence starting at 25, but I don't even know what the common difference is, right? To find the common difference, I would have to take 259, subtract 25, so I'm going up by 234 over a period of 14 terms. So divide that by 14. 234 divided by, I'm going up 13 terms, never mind. I'm starting at term 1, I'm ending at term 14. 1 plus 13 is 14 terms, right? So I take my total distance of 234 and divide by a n value of 13. So the common difference is 18, and I'm doing that n minus 1 times. So hopefully when I do my math summation, I'm using x as n. X goes from 1 to 14 of 25 plus 18 times n minus 1. Phew, got the same answer, 1988. So let's do that one more time. Or you could pause the video, try this example on your own, and then I'll talk you through it. All right, so now I'm going to do it. I'm starting at term 1 up to 18. So 18 divided by 2, I'm starting at 14.72 and I'm ending at 24.41. So 9 times 14.72 plus 24.41. 352.17. 352.17. Let's see if we can get the same answer with sigma notation. So 1 to 18, I'm starting at 14.72. I have to find that common difference again. So what is 24.41 minus 14.72? I went up a total of 9.69 in 17 terms, right? Term 1 to term 18 is 17 terms. So my common difference is 0.57 and minus 1 times. So math summation, I'm going from n being 1 to 18 of 14.72 plus 0.57 n minus 1. 352.17. Phew. So this is a good way of just double checking that we're getting the same answer, that we're not making a mistake in either the formula or the sigma notation. All right, here's just 2 examples where they give you the information in a slightly different way. I'd like you to still try it either using the formula or sigma notation. I'm just going to do one. So let's see, I have 50 terms. I personally like using the formula. So 50 divided by 2 times 29 plus. I need to find the last term. To find the last term, I have to write a formula for myself. 29 plus, what's my common difference? So what's 44 minus 29? 15. So I'm adding 15 each time. I need to plug in term 50 to figure out what the 50th term is. So 29 plus 15 times 49 is 764. 764 is my last term of the sequence. 25 times 29 plus 764 comes out to 19825. 19825. On this one, because I have the formula, it would be easy to check this with sequence notation. So let's see. There's our sigma notation. I'm going from term 1 to term 50 of 29 plus 15 times n minus 1. 19825. Got the same answer. All right. So I'm going to do this next example. And then I had, let's see, 3 application problems, and then you're doing some guided practice. So maybe you want to pause it and try 2B on your own. And now I'm going to do the formula here. Okay, 63 terms this time. It's okay to have an odd number of pairs. It'll still work. I'm starting at negative 19. I need to figure out the last term. So to find out the last term, I need to write a formula. Looks like I'm going up by 6 each time. And I need to plug in 63 to find the 63rd term. So negative 19 plus 6 times 62. 353. So 63 divided by 2 times negative 19 plus 353 is 10,521. And if I want to double check using summation notation, n goes from 1 to 63 of negative 19 plus 6 times n minus 1 came out the same, 10,521. All right, so if they give you some information, you can do a summation, right? All right, so here are a couple application problems for us to go through together. In a staircase, the bottom step has 28 bricks, and each step contains 2 more bricks than the step below it. If there's a total of 50 steps in the staircase, how many bricks are in the 50th step and how many bricks are in the staircase? So finding the 50th step is actually on the way to finding the sum, right? So let me write a formula. A sub n, I'm starting at 28. Each step contains 2 more bricks, right? So that would be my formula. If I plug in 50, I should get how many bricks are in the 50th step. 28 plus 2. Oops, I'm plugging in 50. 28 plus 2 times 49, right? So 126 steps in number 50. So I can use that now in my formula, right? I have 50 steps divided by 2 times 28 plus 126, first plus last. 25 pairs of 28 plus 126 looks like 3850 bricks. Sound good? All right, I'd like you to try example 4 without my help first and then watch the video afterward. So pause the video. Now I'm going to do example 4. So there's a stack of logs in the backyard. There's 15 in the first layer and then 14 and then 13 and then 12. The last layer has 1 log. So how many logs are in the stack? So there must be 15 layers, right? 15 down to 1. So we want to do a summation of 15 rows, right? 15 layers of basically 1 to 15. But I'll say that the first one is 15 and then I'm subtracting 1 each time, right? So my last layer is number 15. Oops, n goes from 1 to 15. I'll do this one with summation, right? I'm doing a summation of n going from 1 to 15 of 15 minus 1 n minus 1 times 120. 120 logs are in the pile, right? And it would be just as easy to do 15 plus 14 plus 13 plus 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and verify that I got the right answer, which I did. All right, example 5, a piggy bank. They dropped $1 on May 1st, $1.75 on May 2nd, $2.50 on May 3rd, and so on until the last day. How much did he drop in his piggy bank on May 19th? And what was his total deposit for the month of May? All right, A sub n is $1 plus 75 cents each day thereafter, right? So if I plug in 19, I should have the total for May 19th. 1 plus 0.75 times 18 days. About $14.15. You cannot read that. $14.50, May 19th. We want to do a summation. How many days in May? 30 days has September, April, June, and November. There must be 31 days in May. $1 plus 75 cents and minus 1 times. Should do it for us, right? All right. N goes from 1 to 31. $1 plus 75 cents each day thereafter. So in the month of May, they deposited $379.75. So you are going to complete these next 4 application problems and send me that guided practice. And that's it for today. Thanks.